Hello, my name is Matthew Jefferson. I am an environmental engineer with the United States Environmental Protection Agency. And today we're going to talk a little bit about scoping and systematic planning for high resolution site characterization. I should note that this is for hazardous waste sites, both in the site characterization or investigation phase and the design and construction. I feel passionately about this for a couple of different reasons. These are typically the plans that we put together, and there's quite a bit of thought process that goes into this. And so the purpose is really to help us appropriately plan for and document those decisions there. So under scoping, we've developed this process called smart scoping, which helps sort of walk through how do we develop those plans in itself. And key components that are involved here is, first of all, looking at both the project core team here, along with a couple of tools that we use, and one of those being site strategy, developing a site strategy, creating or refining a conceptual site model or CSM, and then documenting what type of risks there are with the site in what we call a project risk register. And then as far as maintaining things throughout the lifetime of the project, we want to consider the systematic planning process. So what are the specific objectives that are involved with it? And then what are some of those lessons learned that we have discovered after doing the systematic planning process, and a couple of tips for you guys. What is the smart scoping process? It's basically all the tools that we need to do to be able to plan for our projects and then to execute those plans as the project is going along. So it's 3 steps in thinking about how we go through this process. And so first part is to do what we call preliminary scoping. That's basically how we prepare for what we need to buy in the second step, which is either acquiring a contractor or making sure that we've secured the resources to be able to do whatever work we are planning to do at the site. And then the third step is to check, conduct systematic planning, and really what that is to check to make sure and make adjustments to any of the assumptions that we've made from the preliminary scoping phase. So today we'll talk about steps 1 and 3. Not so much step 2, only because acquiring contractors or resources is specific to your organization, and your organizations may have specific procedures that are unique to them. Some of our goals for smart scoping will be to provide a structured and technical project management approach that's applied prior to and after an acquisition, vehicle, or contract is awarded. In particular, what we want to focus upon is defining what the objectives are for our projects and working with our project teams to define those objectives and clearly communicating them to our contractors before the bidding process and throughout the entire lifetime of the project. In that same vein, we want to also standardize the scoping process. And in my experience as a project manager, I've noticed that the scoping meetings are oftentimes facilitated by a project manager or a contractor that that may have strengths or weaknesses in technical ability or project management skills or task skills. And so I've seen a wide variety of different types of discussions that happen during these particular meetings. And not all the relevant information from a scoping meeting, a scoping plan gets covered during these particular meetings. So what we want to do is provide a series of guidelines for standardizing that particular process. What do we need to cover so that we fully flush out and have captured within our scope? Which leads to being able to document and provide transparency to the process in itself. And so we want to be able to say why we chose what we did in that particular scope and be able to tie it to specific objectives that are out there. And this is really pertinent for cases where we may have a project team or project members that get pulled away from different projects. We want to be able to instill the knowledge that we have and the understanding of why we chose what we did here. We also want to be able to phase the work appropriately. And I've noticed that many of our organizations oftentimes don't have the funding to be able to fully execute all the work, or the resources, or that some of the work happens in certain phases or certain seasons that's out there. So we want to make sure that the work is sequenced appropriately and that it is reflective of all those resource constraints that are out there. Finally, we also want to talk about decisions and how they're informed in the scope, they're informed by the project risk. And so that the risk drivers and the objectives are leading towards decisions, and the work is showing that it's tied to that. The first step in our SMART scoping process will be preliminary scoping. And the purpose of this is to establish a high-level project scope and schedule. So what is involved is the project manager establishes a core project team to be able to help develop and update those key planning documents, whether those documents end up being work plans or quality assurance plans or project plans or specific plans that help develop the reports for either characterization or design or construction. And so another key activity will be for the project team to analyze site strategies, the conceptual site model data gaps, and the project risks to determine high-level project scope and schedule. So we'll use these tools to be able to discuss and determine what we need to plan for each of our activities. So, for example, how many field events do we anticipate having? What will be those objectives for those field events? What are the risk drivers associated with that? So we will use each one of these tools that we're going to discuss in the next following slides to be able to flush that information out. So establishing the core project team is oftentimes thought of in a multidisciplinary approach. And so some of those members of the multidisciplinary team may involve ecologists, toxicologists, engineers, geologists, health and safety individuals, field staff, community involvement or public affairs personnel, those who are involved with reviewing quality assurance and who have a good, deep knowledge of statistics, those who are involved with regulatory and legal experts, subcontractors and vendors, contract management or contract officers that are out there. So not all these individuals have to be a part of your team. And it's really augmented by the other entities as you move through your project or through the SMART scoping process. So you may need certain specialties at different times depending on what issues there are. And it's important to identify also the project stakeholders and decision makers for specific parts of this particular process. So those stakeholders might be individuals that may influence the decisions that you make. For example, the landowners, maybe political individuals that need to be involved. Decision makers included maybe individuals, your management, could be the community members, could be other agencies that get involved. So making sure that you have a plan that addresses all these different stakeholders, and that you have the right people in the right place to be able to define what your project objectives will be. So the tools in our preliminary scoping toolbox, one of them is a site strategy. And what this does is it documents the overall strategy for assessing and remediating a site by prioritizing the high-level goals for the site. For example, maybe we want to provide protection for a certain ecological species or endangered species that's out there. Maybe we want to provide protection for drinking water. Maybe we want to find out what sources of contaminations that are leading to the drinking to contamination seen by in the aquifer. Maybe we want to restore the aquifer to beneficial use. Also included is the listing the key issues and challenges that are out there. Maybe those challenges are technical. For example, we have some fractured bedrock and we don't know where the flow patterns are. Maybe there are funding issues. Maybe there's a very short season that's associated with being able to do field work that's out there. Maybe there is a very steep slope and it's very difficult to get equipment in there. So another thing that we need to outline is the key regulatory activities to achieve these goals. And so what regulations are we're planning to use? What are those vehicles that need to be considered as far as making sure that we adhere to those regulations that are out there? So what processes can we leverage that are part of whatever regulation that's out there? So we also want to provide a rationale for the organization of the site. And this is really important for really large sites. So are we going to divide it up into different segments? Are there some places, some areas that require immediate action, that require action to be taken to be prioritized? Are we going to base our actions on media, geography, or distance to maybe potential receptors that are out there? So these are all things that we want to be able to document in our site strategies. So another tool that we want to use is the conceptual site model. And so traditionally this is thought of as focusing upon the nature and extent, which is frequently the media and transport component here, the third box from the left here. But actually the conceptual site model is a much more complex in terms of integrating decisions and being able to scope those appropriately. So we developed this model here and expanded this particular model to incorporate those decisions that might happen also in the future. So walking through the components starting from left to right, looking at past uses. So what kind of chemicals were there? When was it disposed? And the known disposal, what was the releases that were out there? What was the facility type? What type of operations did they have? Were there any permits that were there? And what was the ownership? And did the ownership change and change those particular practices? The next component is looking at both previous investigations and actions. And so were there any inspections that were done at the facility? Were there enforcement actions? Were there any investigations? Were there any local complaints or complaints from the facility? Were there any releases? Is there any sampling data that was done? And were there any other completion actions or cleanup actions that were done? The media and transport, looking at both the sources and the sources between each one of the medias. So looking at sources, connections between soil and groundwater, sediment, surface water, and air. Another component to consider is also the intended reuse that's associated with it. So what's the current use? What's the surrounding use that's out there? Doing a reuse assessment or doing an assessment on the future use of this area. And what kind of local input would you get from the people who live around there? What is the desire of the community of this particular area? Is this going to still continue to be an industrial site? Do they want to see some sort of redevelopment? Do they want to see a park or another recreational facility? Looking at decision criteria. This is looking at specific goals, not only for the characterization, but what type of goals that we want to adhere to per the regulations. So this is looking at screening levels, action levels, field decision levels, and cleanup levels. As far as the pathway receptor network, we would be looking at sources, what type of release mechanisms are out there, what type of migration pathways. From a human health and ecological standpoint, what are the receptors? What are the sensitive receptors? And what are those exposure routes that we're concerned about? From the technologies and approaches component, we're concerned about the characterization. Is there any type of treatability studies that are out there? What are the factors that influence design? What are the different types of remediation and monitoring that's out there? And this one, the last component, the one all the way to the right here, can be really tricky in some ways. And thinking about how do we get a completion strategy or an exit strategy out there? So what we want to understand is not only how is the site broken down, but also what kind of actions can we take early on in the process. For example, is there something that we can do to mitigate the source that's out there? Looking at priority and phases, looking at different types of contingency plans for the site. So we want to make sure that we integrate all these components and make sure that we document those into our scopes. The last area that we want to cover is project management risk and how we can address those particular risks. And so typically we use something called a project risk register for preliminary scoping. And so this is a systematic process for identifying, analyzing, and responding to project risk. And project risks are areas or concerns or issues that could potentially derail our projects that are out there. So our goal is to identify and execute risk management strategies that will maximize the probability and impact of the positive risk factors and minimize the probability and impacts of the negative risk factors that are out there. So what we want to do is set up where we have all those risk factors and identify mitigation strategies that are out there. So here's an example of a project risk register. And it's basically a spreadsheet where you list all the different types of risk events. And so we describe each one of those risk events here, provide a probability of occurrence. And typically this can be done as a high, medium, low. It can also be some sort of numeric scale that's out there. And then what are the consequences that are out there? A description of what's being impacted. Is it related to scope? Is it related to schedule? Does it have some sort of bearing on our budget? Or does it inflict some sort of contracting consequences out there? What's the magnitude of that impact? And in this particular case, we're using a high, medium, low, but again, you can use a gradation scale, a numeric scale that's associated with it. And then finally, what type of mitigation strategies that are out there? So in other words, how are we going to sort of make sure that this particular risk event, how are we going to address that particular risk event? So after the contract has been awarded or we've secured the resources, we want to make sure we do some systematic planning throughout the lifetime of the project. And so systematic planning is a process for building consensus vision for conducting environmental investigation and remediation. And this can be really thought of in a lot of ways for doing scoping all throughout the execution of the project to make sure that our project objectives, that we are meeting the project objectives. So systematic planning does help avoid having way too much data that does not enhance the understanding of the site. In other words, it does not meet the objectives of the site. Or in the opposite case, not having enough data to be able to make decisions. And so this does provide a structured approach for us to be able to plan the remainder of the work throughout making decisions or cleaning up the site. Some of the systematic planning activities include achieving consensus on those preliminary project goals that we help develop during preliminary scoping, understanding what the authorities are, and getting an idea of what the lines of communication between the stakeholders, the decision makers, the project team, and the field team. So also it gives us an opportunity to review those critical tools that we help develop in the preliminary scoping phase. That includes the site strategy, the risk register, and the conceptual site model. Through that process, we wanted to further refine and understand what those data gaps and the areas of uncertainty are. It's a finer definition of the conceptual site model in itself. And then we want to get into more detail in understanding how we're going to resolve the issues with the site. And especially if we're dealing with a field mobilization, we want to understand what the real-time measurement technologies that we can use to help quickly assess sites. And then we want to evaluate our completion strategies, going back to seeing whether or not the data that we've collected helps us, really truly helps us, or do we need to make different contingencies or make some different performance or define better performance metrics to be able to achieve the goals for the site. So some of the lessons learned that we've observed through the scoping process is, first of all, come prepared and make sure that the other team members also are prepared for the discussion. So in doing so, what helps teams is to be able to distribute the current draft of the site strategy, conceptual site model, and the risk register. And if there's a proposal to do a new technology, be prepared to explain it. Be prepared to explain it to other folks who don't have as much knowledge of the technology and how it would get implemented through the process in itself. What I find is very helpful is to include a site visit if that's all possible. Being able to understand the spatial geology or juxtaposition of different elements and how it relates to the site and the scale of the site is particularly important. And I can't emphasize this more, but it's important to bring in a good, strong core team. To have the expertise there to be able to discuss that, to fully flesh out the details is particularly important. And another thing I'd like to emphasize is identifying an independent facilitator. That can be really helpful in terms of being able to discuss, record, and be able to capture all the ideas that come from these scoping sessions. During these meetings, it's also important to use active listening and participation. And so part of my duties as a facilitator now is to identify the concerns and issues that are out there and to seek resolution for disagreements. And that may be including gathering some more information, doing some research that's out there, identifying a certain type of expert, identifying sites that have done similar actions before, seeking advice from other organizations that have dealt with similar types of issues, but basically providing some way to find a way to resolve the issues that are going on with the site by bringing in different types of perspectives that are out there. Another point is to stay focused on relevant issues. And so in order to do so, it's important to develop and follow a detailed agenda and to have a sort of a parking lot or to table those non-critical discussions that are out there, because there is a tendency to be able to meander or get off topic. And it can be a real challenge to be able to stay focused on what the issues are. So, when developing those agendas for systematic planning or for scoping, is to identify what the clear endpoint is. What is our objectives? What are we sitting down to be able to do? Is it to resolve field issues? Is it to get to a certain stage in the regulatory process? What are we doing, and how are we going to get it done, and what's the timing associated with it? So if you'd like to learn a little bit more about smart scoping, we've got two guides. The one on the left-hand side is one that we published back in October 2020. It's the smart scoping of a EPA remedial investigation and feasibility study, where we walk through the process that we've described here in more detail, talk a little bit about more of those tools for preliminary scoping and systematic planning. And then the one on the right-hand side is the technical guide to smart scoping, which dives a little bit more into the systematic planning processes, the different types of tools and technologies that are available to help with planning and scoping your projects.